So we've integrated a few different versions of the reverse chain rule now, and we're now going to look at one that works with brackets. As with all good integrations, this starts with reminding you of a differentiation, and particularly we're going to be looking at using the chain rule here. What do you get if you differentiate fx to the power of n? Well, if we say that's y or whatever, we can say that we have y equals u to the power of n. We can say that u equals fx, and we have ourselves a chain rule. To do the chain rule, we would dy du to get nu to the n minus 1 times by the power drop the power. And we would do a du dx to get f dash of x, which just means literally the differential of f of x. As it's a chain rule, we then multiply those two things together to get that dy dx is equal to, and I'm going to write it in this order, n f dash of x times u to the n minus 1. So let's substitute our value of u back in there, and we can get that dy dx is equal to n f dash of x times fx to the n minus 1. And that is actually a shortcut that we looked at in the chain rule. Now, what's the point of that? Well, again, if we can differentiate going this way, then we can integrate going the other way. So if we have something that looks like the right-hand side of that equation, we know that we can integrate it to get just the integral of dy dx, so just y. And let's write that down properly. Let's maybe rub out the bit that's going in the way. So if we integrate something that looks exactly like n f dash of x fx to the n minus 1, then we'll just get fx to the n. So let's use this. So my particular way of doing these types of questions is very prescriptive, and there are other ways which involve a lot more sort of playing around with integrals and trying to get them to work. If you don't like this method, I will probably be looking at that in the new year. But for now, let me just show you how I think this works. So I want this to look like the version of the shortcut that we've got up there. And we're going to start from the right-hand side because it makes it easier. I want this n minus 1 to be this 7. So what does that tell me? If that's n minus 1, then that tells me n equals 8. I want this fx to be what I'm raising to that power. So that tells me that fx is equal to x cubed plus 1. And finally, I want this bit to look like n f dash of x. So we need to check what n f dash of x is now that we've worked out what n and fx is. So let's do that. N f dash of x is equal to 8 times, now the differential of x cubed is 3x squared, is equal to 24x squared. And yeah, so this is exactly equal to n f dash of x. So we've got something which looks exactly like the form on the left, which means when we integrate it, we'll get something that looks exactly like the form on the right. It'll look like fx to the n, which will be, in this case, x cubed plus 1 to the 8. Plus c, probably. Now that was the ideal case. That was the one where we didn't have to do any messing around with it. It was just worked perfectly first time. That's not always going to be true, and these next few examples will show you how. So let's start with this one. Again, we start from the right-hand side. We increase this by 1 to get what n is, and we take whatever is inside the bracket to be what f of x is. Then we're going to figure out what n f dash of x is, which is going to be 4 times 6x. So that's 24x. And here we've got a bit of a problem because we don't have 24x at the start of our integral. We've got 2x. So what do we do about that? Well, we make it work. Let me show you how we're going to do that. We're going to write down the integral that we would like to see. We would like to see this because we know that this integrates to fx to the n, that it integrates to 3x squared plus 1 to the 4. And then we're going to say, well, that's not quite what we've got. We've got 2x, not 24x. So what would we need to multiply that 24 by to make it 2x, to mean that we haven't changed anything? And that would be a 12th. So it's true to say that these two integrals are now exactly the same. We've just taken out, I suppose, a factor of 12th. And so we should take out a factor of 12th in our answer as well. And we're done. So you write down the integral you'd like it to be, and you work out what factor is required to make that true. Plus C. Here's a trig version of that catches people out. Remember, if we say something like sine squared of x, then all that really means is sine x all squared. And so in this case, our n is going to be 1 more than 2, it's going to be 3. And our fx is going to be sine x. So we need to find an expression for n f dash of x, which is going to be 3 times cos x. So it's 3 cos x. We already have that at the front, so this is already in the form n f dash of x. So we're good. We can just go to fx to the n. We can just go to sine cubed x plus c. Let's look at one more, which could be a bit of a bother because we have got something that looks like a quotient rule here. But always remember that you can rewrite powers that are on the bottom as negative powers on the top. So we could rewrite this as e to the 4x times e to the 4x minus 3 to the power of minus 3. And then we'll go through the same process. So what's our value of n? Our value of n is 1 more than minus 3, which is minus 2. What's our fx? Our fx is whatever's in the bracket, so is e to the 4x, take away 3. And then we need to work out n f dash of x, which is going to be minus 2 times, and if we differentiate that, it's going to be 4e to the 4x, bit of chain rule there, which would be overall minus 8e to the 4x. So we look at what we've got, that's not quite true. So we're going to write down what we would like it to be. We would like this to be minus 8e to the 4x times e to the 4x minus 3 to the minus 3. Because we know that that would integrate to fx to the n. That would integrate to e to the 4x minus 3 all to the minus 2. However, it isn't, so we need to think, well, what factor would make this work? Well, what would we need to times minus 8 by to make it into just 1? We need to times it by minus an eighth. So that's the same thing, which means we need to put our minus 1/8 over here as well, and that's our answer, plus c. So yeah, that's the last of the reverse chain rule shortcuts for now. Have a little play around with it, see how it goes.